So then, I think all right, no, all good, right? All good, and we can start the story. We can start the story today. It's our third theory class day, but this is our fourth class. First week we did a small introduction, and last 2 weeks we were talking about units theory sections, and we completed all the theories in units section. Today we are talking about dimensions. Dimension section is somewhat complex, not difficult. When you're comparing with unit section, dimension section is somewhat complex, not difficult. Okay, but these are very basic ideas. Right now, stay focused. Today we are in the class from 6 to 9. We will take a break in between. But till the first break, keep your focus, stay focused. Always keep a motive. The time that you are spending right now, you should spend effectively. Right? Therefore, stay focused and learn something new. Right? Today, I think we can do huge number of questions today. Right? So today we are starting dimensions ideas. I will tell you what is dimensions, and I will step by step, I will explain each and every point step by step, and I will ensure everyone joining for the class, I will ensure that you will be able to understand. But I'm expecting only one thing from you, your focus. Stay focused, right? Then these stories are very simple stories, right? So then we discussed all the theories regarding unit section, and we have done some questions in units ideas. Today we are starting dimensions, right? That story. Mostly I think today and next week also we might have to do dimensions theories and questions. Thereafter we can start from April onwards, we can start unit 2 vectors theories, as well as unit 1 measuring instruments. That story put in your mind. We'll start the idea, right? Now dimension stories. Before going to dimensions, in maths we learned about exponents. That theory idea we learned in maths, O-level maths. We learned the idea, right? Powers, if not exponents ideas. That is somewhat important to do some calculations. Now theory, now new section. I think first time only you are learning dimensions. I don't think you learn dimensions in your O-levels. I don't think. Dimensions. Dimensions. Dimensions of what? Dimensions of physical quantities. Units of what? Units of physical quantities. Dimensions of physical quantities. Let's try to understand, sir, what does it mean by dimensions of physical quantities? We'll try to understand that idea. Right. Okay. So we learned, we learned what is a physical quantity. And we can give plenty of examples of physical quantities, and we can categorize physical quantities into vectors, scalars, and then we talked about base physical quantities and base units, and we talked about supplementary and derived, special names, compound names, compound special names. We know the idea of physical quantity, we know, right? If I ask you, what are the main 3 measurements that you take in your day-to-day life? We learned already mass, length and time, right? Those are the 3 main measurements that we obtain in our day-to-day life. Now, dimensions of a physical quantity means, remember, dimensions of physical quantity means this idea. Dimensions of a physical quantity means what? Of a physical quantity. Physical quantity. Physical quantity means how the physical quantity, how any physical quantity is linked with mass, length and time, right? So we are going to build a relationship how each physical quantity is built in terms of mass, length and time. That is the idea, right? Now I mentioned go to the tute and page number. In the tute page number, if you go to the tute, I will share the tute PDF once again in the WhatsApp group. If you are not in the WhatsApp group, I will put my WhatsApp number here. Please put a WhatsApp message, then I can add you in the group, right? So just refer the PDF, go to the tute page number, we'll talk next story, page number 10 story. And if you are not in the group, you can put a WhatsApp message, WhatsApp number 075 799 7893, right? Okay. So then sir, today lesson is dimensions, and I want to understand what does it mean by dimensions of physical quantity, right? Very simple. So this shows a relationship between mass, length and time, how mass, length and time link with that certain physical quantity, right? Just read that first sentence. The dimensions of physical quantity are the powers, exponents to which the base quantities are raised to represent the quantity. Okay, I will explain, don't worry. I will explain. It is a symbolic expression that shows how a derived quantity is constructed from the fundamental dimensions. In Newtonian mechanics, all physical quantities can be expressed using just 3 fundamental dimensions. Okay, right. So then, when you consider every physical quantity, they are linked with base physical quantities like mass, length and time. For an example, if I tell that, let's say density means, we all know that density means mass over volume. The volume is linked with length, no? So therefore, we know when you consider density, that physical quantity, that is linked with mass and the length, no? Volume is what? Volume is also linked with length, no? Length into width into height is the volume. So dimensions means dimensions of a physical quantity. Dimensions of density means we are analyzing how that physical quantity is linked with fundamental physical quantities like mass, length and time, right? That is what we call as dimensions of a certain physical quantity, right? So then the topic is the 3 fundamental dimensions. Number 1 is mass, number 2 is length, number 3 is time. Look here. There are 3 fundamental dimensions, right? So there are 3 fundamental dimensions. Okay. There are 3 fundamental dimensions. There are 3 fundamental, if not fundamental dimensions. Just write down in that table 3 fundamental dimensions. Number 1, write down mass. The first one is mass. Second one is write down length. Third one is write down time. Okay. Mass, number 1 is mass. The dimensions, the symbol that we assign to represent dimensions of mass. The symbol that we assign to represent the dimensions of mass, that is capital M. That is capital M. Right, in the right side column, write down symbol under symbol, dimensions of mass, the symbol is capital M. Right. Number 2, write down length. Number 2, length. The symbol assigned to represent the dimensions of length, that is capital L. Capital L. Number 3, write down. Number 3, in that table, write number 3, time. 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 The symbol that we assign to represent the dimensions of time is, that is capital T. That is capital T. right? That is capital T. So then basically, sir, one last time, shall we define what does it mean by dimensions of physical quantity? When you consider any physical quantity, in order to analyze how that physical quantity is linked with mass, length and time, we are giving some symbols for mass, length and time, and we are obtaining a kind of symbolic expression in terms of mass, length and time. Each and every physical quantity. Then that is what we call as dimensions of that physical quantity, right? So you will understand, don't worry. The next idea. Write down red color pen, write an important point. Red color pen, important point, write down red color pen. Write down. The standard symbol used to denote the dimensions of, write down. The standard symbol used to denote the dimensions of, the standard symbol used to denote the dimensions of a physical quantity is square brackets, square brackets, square brackets, square brackets, square brackets. Highlight standard symbol, dimensions of square bracket. Standard symbol, dimensions of square bracket. Highlight. Right, okay. That idea explains, look here. This idea, look here. This idea. Okay. Let's say now, you definitely in your exam, they ask us to find the dimensions of different physical quantities, right? So then, for an example, you may have to find the dimensions of velocity, dimensions of acceleration, dimensions of density, right? Rather than writing dimensions of, you can replace. Look here, for an example. If you want to find the dimensions of velocity, look here. I want to write down dimensions of velocity. Dimensions of velocity. Rather than writing this term, dimensions of, what you can do, if you write down velocity, inside the square bracket, it says that, it depicts that dimensions of velocity. If you write down velocity inside the square bracket, it says, it explains, when someone look at this idea, it says that dimensions of velocity. So very simple. What does it mean by dimensions of physical quantity? Dimensions of physical quantity means it's a kind of symbolic expression that shows the relationship between certain physical quantity and physical quantities like mass, length and time, right? So we are assigning symbols for mass, length and time. Mass capital M, length is capital L, time is capital T, and we are obtaining a relationship between mass, length and time with that physical quantity. Okay, the symbol to represent dimensions of is a square bracket. If you write any physical quantity inside the square bracket, the meaning is dimensions of that physical quantity. Do you understand? Right? Now, next story is, I told you the symbols of dimensions of mass, length and time is capital M, capital L, capital T. Right? This capital M means, you can just think this capital M symbol is came because of the first letter of mass is capital M, therefore capital M. First letter of length is capital L, therefore dimensions of length is capital L. The first letter of time is capital T. From that exposure, they consider dimensions of time as capital T. Thing like that. That story. Okay. That idea is also done. Okay. Now still I think you are not 100% understand the idea. What shall we do for an example? Let's say now the basic ideas. Let's take a speed. For an example, we know. So we know the equation for speed is we know. We learned in our O levels also. Speed is what? Speed means distance over time. A speed equals distance over time. Distance over time. Now in case if they are asking us to find the dimensions of speed, what you want to do? If I want to find the dimensions of speed, if you write this physical quantity speed inside the square bracket, it says that dimensions of speed, right? Remember, if you want to find the dimensions of speed, please write down speed inside the square bracket. It shows that our dimensions of speed, that should be equal to dimensions of distance over dimensions of time. You understand? So we know the equation speed. I want to find the dimensions of speed. Then if you write down speed, distance, time inside square brackets, they explain dimensions of speed equals dimensions of distance over dimensions of time. Right? Then we know that I want to find dimensions of speed. We know dimensions of distance is how much? That is, distance is basically a length. Dimensions of distance is capital L. Right? Dimensions of distance is capital L, no? Capital L. Right? Over dimensions of time, that is capital T. Then we can write down capital T is at the denominator. What is the power of this capital T? Power of capital T is 1. When this T to the power 1 goes to the numerator, it becomes T to the power minus 1. Therefore, we are getting the final answer. Dimensions of speed going to be L T to the power minus 1. L T to the power minus 1. So we actually, now what we have done actually, right now we wrote the physical quantity speed in terms of, look here, what have we done is we try to understand how the speed is linked with mass, length and time. So we realized the speed is linked with length, power is 1. The speed is linked with the time, power is minus 1. But speed is not linked with the mass. Since there is no capital M term, now we can understand, if you write the dimensions of a certain physical quantity, you can analyze, you can understand how each and every physical quantity links with mass, length and time. You understand? So this is the idea of finding dimensions of a physical quantity. Is the idea. Right? Now test me question. In the tute, test me question, find the dimensions of below physical quantities. Start doing those 3 examples. In the tute, go to the tute and page number 10, test me question. Start finding dimensions of those 3 physical quantities. Start finding. I'll give some time. Time is 6:22. Maximum 3 minutes. Right? It won't take that much of time. Maximum 3 minutes. Quickly find the dimensions of area, volume and speed. Speed already explained. Find the dimensions of area, volume and speed. Start doing. Start doing. Don't waste your time, okay? A very simple idea. Dimensions of physical quantity means, right, it's a kind of relationship that we obtain in terms of mass, length and time for that physical quantity. How every physical quantity links with mass, length and time. If we can represent it as a symbolic manner, then that is what we call as dimensions of that physical quantity. Right? Very simple idea. Quickly do the test me question. Test me question. Right, okay. So then I'm also doing time is 6:25. I will explain those test me questions and we'll go to next theories. Keep on doing. Keep on doing. And if you have any doubts, you can ask your doubts, right? You can reply to YouTube chat. Today will be the last day that we are streaming the classes via YouTube. Next week onwards, we are moving to Zoom classes, right? Since it's our very first month, therefore decided to do the classes via Zoom and thought of providing free access for everyone who really wants to learn a subject like physics properly. So therefore get the benefit from that. Don't waste your time. Give your 100% focus and learn each and every point clearly. In case if you are not clear about one point, please don't hesitate to ask your doubts. Right? Subject like physics, we should never keep the doubts. So when a doubt arises, immediately ask your doubt and clarify it and sort it out. If not, you will fall in a danger. Right, okay. So then if I do the test me question, I want to find the dimensions of area, then volume. Test me questions. Test me questions. Right? Okay, test me questions. Area. I want to find the dimensions of area. So area means we know they have given equation, the area x, length into breadth, length into width, if not length into breadth, area equation. Area equals length into width, if not breadth. Right? Okay. Since I want to find the dimensions of area, represent every physical quantity inside a square bracket. Right? If you write area inside a square bracket, the meaning is dimensions of that physical quantity. Dimensions of area. Therefore, I can write down dimensions of area equals dimensions of length. So include each physical quantity inside the square bracket. Dimensions of length into dimensions of breadth. Right? Simple. Then we know that length is a length. What is the symbol assigned for the dimensions of length? That is capital L. Right? So dimensions of length is capital L into dimensions of breadth. Breadth is also a length. The symbol assigned to represent dimensions of length is capital L. Then L into L. Then what must be the dimensions of area? That is equal to L into L means L squared. L into L, that is L squared. L squared. Dimensions of area equals L squared. Not difficult, simple idea. Very simple idea. L squared. You know that if the base is same, what should be the power of these two bases? Power is 1. L to the power 1 into L to the power 1. The base is same, you can add their exponents, you can add their powers. 1 plus 1 going to be 2. 1 plus 1 going to be 2. Therefore, area dimension equals L squared. L squared. Clear? Likewise, I think I found the dimensions of velocity. Okay, number 2 is volume. No? Number 2 is volume. We know volume means length into breadth into height. Second one is volume. Equation for volume equals length into breadth into height. breadth into height. Okay. So if you want to find the dimensions of volume, we can write down dimensions of volume equals, if you write the volume inside the square bracket, the meaning is dimensions of volume equals dimensions of length into dimensions of breadth into dimensions of height. Right. So length is a length, dimensions of length is capital L. Breadth is also a length, dimensions of breadth is capital L. Height is also a length, therefore dimensions of height is also should be capital L. L into L into L. Therefore, what is the final answer? If the base is same, what is the power of these L? 1, 1, 1. So you can add their powers. 1 plus 1 plus 1 is 3. Dimensions of volume is how much? L to the power 3. Simple. Really simple idea. Really very simple idea. Volume dimension is what? L to the power 3. Likewise, find the last one. Last one is they have given the speed. Speed dimension is already I found. Speed is distance over time. Distance dimension is capital L. Time dimension capital T. Therefore, dimensions of speed should be L T to the power minus 1. Simple. Simple. Right. I think idea is clear. Idea is clear, no? Idea is clear. Right? Done. This story is finished. So dimension, what does it mean by dimension of physical quantity? That idea. Then the symbols of mass, length and time, capital M, capital T. Then to represent dimensions of, we are using a symbol that is the square bracket. Whenever you write the physical quantity inside the square bracket, the meaning is dimensions of the physical quantity. Right, then we found dimensions of some physical quantities. Now we understood the idea. Very clear. Basically, dimensions physical quantity means a kind of expression, symbolic expression, which shows the relationship between mass, length and time, how mass, length and time link with that certain physical quantity. That is the idea. That is the idea. Right, then we'll go to the below that under page number 10, the next important point write down. Next important point write down. Next important point write down, red color pen. Red color pen write down. Red color pen. Write down write down. Okay. Write down. Now idea is clear, no? I hope that everyone understood the idea of dimensions of physical quantity. Right, red color pen write down below. Under page number 10, the last point write down, red color pen. When we say a quantity does not have dimensions, write down. When we say a quantity does not have dimensions, comma, when we say a quantity does not have dimensions, comma, when we say a quantity does not have dimensions, comma, we mean it is a dimensionless quantity. We mean it is a dimensionless quantity. We mean it is a dimensionless quantity. Right? Red color, an important story. Okay. Right. Now what shall we do? We'll jump into some stories. We'll go to some questions and we'll find the dimensions of some physical quantities and then we'll come back to those theories. Right, now go to the page number. Again, we are doing question number 1 once again. Again, we are trying question number 1 once again. Right, go to the page number 15 and question number 1. Already we found the units of those given physical quantities. Once again, find the dimensions of those physical quantities. Everyone start finding the dimensions of those physical quantities. Everyone start finding the dimensions of those physical quantities. Start finding. Page number 15, question number 1. Area, we found the dimensions, velocity. Keep on doing. Page number 15. Page number 15, question number 1. Now question. Page number 15, question number 1. Right? Number one is dimensions of area already found. Area dimensions already found. Then velocity. Keep on finding the answer. I'll give some time, but I don't give that much of time. Just keep on finding the dimensions of each and every physical quantity given in the question. Keep on doing. Keep on doing. Right, keep on doing. Right, keep on doing. Keep on doing. Now, velocity means question number 2. Velocity means displacement over time, right? Velocity means question number 2. Displacement over time. The equation. Velocity equals displacement over time. Displacement over time. Then the dimensions of velocity equals dimensions of displacement over dimensions of time. Displacement is a length, therefore dimensions of displacement is capital L, no? Capital L. Capital L. Over dimensions of time is capital T. When capital T comes to the numerator, it becomes capital T to the power minus 1. It becomes capital T to the power minus 1. Therefore, dimensions of velocity equals L capital T to the power minus 1. Simple. Likewise, keep on doing all those 22 MC questions. Keep on doing. Don't waste your time. Keep on doing. If you have any doubt, you can ask. Right? Till the first break, we'll keep on working. Till our first break, we'll keep on working. Right? Okay. Question number 3. Number 3, acceleration. Acceleration means velocity over time. Right? Third one is keep on doing the questions. Acceleration. Acceleration means velocity over time. Then tell me, dimensions of acceleration means dimensions of velocity over dimensions of time. So velocity dimensions, just now I found dimensions of velocity, that is L t to the power minus 1. Right? L t to the power minus 1 over dimensions of time is capital T. Capital T. What is the power of this capital T at the denominator? Power is 1. When capital T to the power 1 goes to the numerator, it becomes capital T to the power minus 1. Clear? No? When this capital T to the power 1 goes to the numerator, it becomes capital T to the power minus 1. Then what is the final dimensions of acceleration? L there are two capital T terms, no? Capital T to the power minus 1 into capital T to the power minus 1. Same base, therefore you can add their exponents, you can add their powers, minus 1 plus minus 1. If I add their powers, minus 1, that should be minus 2. Therefore, dimensions of acceleration is L T to the power minus 2. Simple. Simple. Fourth one. Force means mass into acceleration. Fourth one. Force equals mass into acceleration. Mass into acceleration. If you want to find the dimensions of force, that should be equal to dimensions of mass into dimensions of acceleration. Really simple story. Very simple logic. Really simple logic. Mass dimensions capital M. Acceleration dimensions I found, that is L T to the power minus 2. Therefore we can write down dimensions of force going to be capital M L T minus 2. Capital M, capital L, capital T to the power minus 2. Simple. Next one. Number 5. Pressure means force over area. Pressure equals force over area. Force over area, area. Dimensions of pressure is what? Dimensions of force over dimensions of area. Now keep on doing. Don't waste your time. You guys keep on doing, keep on working. Force dimensions, that is ml T to the power minus 2. Area dimensions I found, that is L to the power 2. Therefore, dimensions of force going to be capital M, capital L, capital T to the power minus 2 over capital L squared. Now here we know that we can cancel out one capital L term, right? So we all know that capital L squared means what? Capital L squared means L into L. So therefore you can cancel out one capital L term. Then at the denominator the remaining is only one capital L. When this one single capital L goes to the numerator, it becomes capital L to the power minus 1. Finally we can write down dimensions of pressure going to be, remember, capital M, capital L to the power minus 1, capital T to the power minus 2. You understand? But when you're writing the dimensions, the proper order is normally we write the mass, then only the length. Lastly only we write the time, right? Capital M is the first letter, second letter is capital L, and the last letter is capital T. That is the way normally we write the dimensions of a certain physical quantity in that way. Practice in that way. Simple, no? Likewise, now 5 done, we have to do 20 to be done. Keep on doing the remaining questions also. Keep on doing, don't waste your time, keep on doing the remaining questions also. Don't waste your time, keep on doing the remaining questions as well. Keep on doing. Right, keep on doing. Density means mass over volume. Next equation. Next equation, question number 6, sixth one, right? Sixth one, density means mass over volume. Mass over volume. Mass over volume. So dimensions of density should be equal to dimensions of mass over dimensions of volume. Mass dimension, that is capital M. Volume dimensions, that is capital L cube. Dimensions of volume is capital L cube, right, over capital L cube. When this L to the power 3 as the denominator goes to the numerator, when this L to the power 3 denominator goes to numerator, it becomes what? Capital L to the power minus 3. Therefore, we can write down dimensions of density is what? Capital M, capital M, capital L to the power minus 3. Simple idea. Simple idea. Next story. Number 7. Number 7. Number 7. Work done means work done if not energy means what? Force into displacement. Right? Work done if not energy means what? Force into displacement. Force into displacement. So dimensions of work done if not energy, it should be equal to dimensions of force into dimensions of displacement. Force dimensions, just now I found force dimensions I found that ml t to the power minus 2, right? ml t to the power minus 2, capital M, capital L, capital T to the power minus 2 into displacement dimensions, that is capital L, capital L. Now we can clearly see that there are two capital L terms. We can clearly see there are two capital L terms. What is the power of this capital L? Power of this capital L is 1. Power of this capital L is also 1. Same base, capital L, same base, capital same base. In that case, what you can do, you can add their powers. Then 1 plus 1 is 2. Therefore, we can write down the dimensions of work done if not energy is, remember, capital M, L squared, 1 plus 1 is 2, capital T to the power minus 2. Right. 8th one. Question number 8. 8th one. Number 8, power means energy over time. Next equation, power equals energy over time. Power equals energy over time. If you want to find the dimensions of power, dimensions of energy over dimensions of time. Now, this is very real. Do you think that these are very complex? Do you think are these complex? Not right. So there is a small pattern. We understood what does it mean by dimensions of physical quantity. Right? This is really just basic stories. It's really simple story, no? Is it difficult? I don't think that anyone in the class they feel like this question is very difficult. No, right? Very simple question. It's really simple. Right? It's really simple. If you know this exponents and power of the bases, then this story is very, very, very simple. Energy dimensions I found, that is ml squared t minus 2. Capital M, capital L squared, capital T minus 2 over dimensions of time is capital T. What is the power of this capital T as the denominator? It's 1. When this t to the power 1 goes to the numerator, when this capital T to the power 1 goes to the numerator, it becomes capital T to the power minus 1. Right, then already there is capital T to the power minus 2 into capital T to the power minus 1. Same base, minus 2, minus 1. You can add them together. Same base, capital T, you can add their powers. Minus 2, minus 1 is minus 3. Therefore, we can write down dimensions of power is, remember, capital M, capital L squared, minus 2 minus 1 is minus 3, capital T to the power minus 3. This idea. Number 9. Ninth one. Frequency means 1 over time. Frequency means 1 over time. Frequency means frequency equation is what? 1 over time. 1 over time is Ti simple me. Right? So then dimensions of frequency should be equal to 1 over dimensions of time. This is somewhat different than previous equations. Remember, frequency dimensions equal to 1 over dimensions of time. Some people have a problem, sir, then don't we want to consider a dimensions of 1? We will learn after doing this question, we will learn the, remember, constants. They don't have dimensions. Therefore, we don't put the dimensions of 1, right? This theory point we will talk in a while. After completing this question, I will give this point. Then 1 over dimensions of time is capital T. As capital T goes to the numerator, it becomes capital T to the power minus 1. Therefore, frequency dimension is capital T to the power minus 1. Number 10 is again torque. Torque is also what? Force into perpendicular distance. Torque is what? Force into perpendicular distance. Torque is what? Not very simple story, it's not difficult. A torque equals what? Force into perpendicular distance. The same idea. Force into a perpendicular distance. Force into, I don't write perpendicular, I just write on distance. Okay. Right. Therefore, dimensions of torque should be equal to what? Should be equal to dimensions of force into dimensions of work done. My bad. Dimensions of force into dimensions of distance. Force dimension is ml t to the power minus 2, ml capital T to the power minus 2. Dimensions of distance is capital L. Then there are two capital L terms, L to the power 1 into L to the power 1. The result is what? Capital M, capital L to the power 2 into capital T to the power minus 2. So torque dimension is also capital M, L to the power 2 into capital T to the power minus 2. Clear now? Number 10. Number 10. Right? Likewise, I will give some time. There is another 10 to go. Keep on doing remaining 10 also. Just keep on trying remaining 10 also. Then this idea, overall idea is finished. Keep on doing remaining question 10 questions. Keep on doing. Keep on doing. Keep on doing. Keep on doing. Time is 6:51. I will give another 5 minutes. Okay. Time is 6:51. I will give another 5 minutes. Keep on trying the questions. Keep on doing. Keep on doing the questions. Keep on doing. The time is 7 o'clock. No, 1 hour is finished. The time flies. Time flies very fast. Right? The time is flying very fast. We don't waste our time. Keep on doing the remaining 10 questions. Keep on doing. Keep on doing. All right. Question number 11. What is 11th one? Question number 11. Number 11. Number 11. Keep on doing. Keep on doing them. Next story. Keep on doing next story. 11th one. And if you have finished all those 22, don't try that question number 14. There's a small problem, no? Other than question number 14, try remaining 22 questions. Other than question number 14, right, in that question set. Don't try question number 14. Try all the remaining questions till 22. If you finished, just put a small thumb something in the YouTube chat. Okay? Now keep on working. Just keep on working. Keep on working. Right? Number 11 is surface tension. Number 11, surface tension. Number 11. 11th one is surface tension. Surface tension, that is equal to what? Force over length, no? Force over length. Force over length. Now, it takes less than 1 second to get the answers. Therefore, quickly keep on getting the answer. We will talk about next theories and we'll complete the dimensions chapter and we'll start the real physics thereafter. The real physics is waiting for you people. Once we completed this section, we can start the real physics that is waiting for you all. Force dimensions mlt to the power minus 2 and dimensions of length is capital L. mlt to the power minus 2. Length dimension is capital L. Then we can cancel out these two capital L's and the remaining is capital M into t to the power minus 2. We are getting dimensions of surface tension as what? Capital M into capital T to the power minus 2 is the idea. Is the idea. Right, question number 12. Don't try 14 till question number 22. Then question number 12. Number 12. I think already you have the idea, but we'll complete the question and we'll start discussing next theory sections. Number 12. Young's modulus means force into length over area into change in length. Young's modulus. That is equal to force into length. Force into length over area into change in length. Area into change in length. Remember, change in length is also a length. Do you understand? Remember, change in length is also a length. Area into change in length, that is also a length. Change in length. Right, change in length. Right. So then dimensions of Young's modulus should be equal to separately consider each physical quantity and obtain their dimensions. Separately consider each physical quantity and obtain their dimensions. That's it. Dimensions of force into dimensions of length into over dimensions of area into dimensions of change in length. Story. Simple. So dimensions of force is capital ML capital T to the power minus 2. Capital ML capital T to the power minus 2 into dimensions of length is, that is capital L, over dimensions of area is capital L squared. You can remember now the stories. And in the change in length dimension is also capital L. Remember, this change in length is a length. Some people, they don't understand. Remember, change in length is also a length. Therefore, what should be the dimensions of change in length? That should be also capital L. Capital L. Then we can cancel out this capital L in the numerator with this capital L at the denominator. You can cancel out these two. And also we can cancel out this capital L in the numerator with, now there is L squared at the denominator. Therefore, you can cancel out one capital L in the denominator with this capital L in the numerator. Then there is only one L remaining at the denominator. If you move this capital L, add the denominator to the numerator. It's going to be L to the power minus 1. It's going to be capital L to the power minus 1. Finally, we can write down Young's modulus dimension is going to be capital M. When this capital L goes to the numerator, it becomes capital L to the power minus 1 into capital T to the power minus 2. Simple story. Nice. Number 13. Few more to go. Number 13. Then volume story we learned, no? Volume dimensions already I found, therefore I don't write here. Volume dimensions we already done. 14, I said there's a problem in the question, therefore no any problem in the question, it's correct, but don't try question number 14. Don't try 14, start doing 15. Number 15. Next story. I remember now, if you are doing A-level math science subjects now, I think already A-level class started then. Now I think it's been almost 1 month. You might have tried many classes, but one story I will tell you. If you are doing math science subjects, I will tell you one story. Right? You should 100% focus the lesson. Okay? You can't play after you come to the A-level math science subject streams. You can't play, okay? You can't study the way that you want also. Okay? So therefore, now you know how this, you have a kind of understanding about math science stream since you have joined for some classes. Therefore, adapt to the A-level class pattern. If not, you will suffer. Right? So you might, everyone are doing A-level math science subject for a reason. Some of you might have to become a doctor. Some of you want to become an engineer. Some of you want to become some other right professions. If not, some of you do math science subjects to get A's. Some of you really interested doing math science subjects than other subjects. Therefore, remember what is your motive. Always keep your motive and keep on working. Once you join for a class, remember till the class completely finishes, you can't tell that class is boring or I don't understand. Maybe some classes if you attend, you feel like you don't understand. But I can guarantee anyone at any level join to my class, everyone will be able to understand every point. Because we are teaching in that level, therefore, till the last moment, stay focused, learn every idea, always remember why you are doing A-levels, why you are doing math science subjects, while your father's friend is doing commerce streams, art streams, why you are doing math science subjects. Always keep that motive and work. Keep that motive and work. Always think in a class, every class, you should have a curiosity. Right, before class starts, you should have a curiosity. What lesson am I going to learn today? What are the new theories, new ideas that I will learn today? You should have a curiosity. And also remember, every class finishes, you should learn something. Right? So therefore, always stay focused and learn. Focus and work. If you start from now, definitely getting 3 A's is not a big deal. Okay? I'm there to help you. We have a very big work plan to be done. This is our first month and we are just doing few classes. But we have a very huge work plan to be done. Therefore, we'll work together and we'll go for a nice result. I can guarantee A result for this subject. And also I will guide you how to get A's for chemistry. If you are doing combined maths, I can give a small support how to get A for combined maths. But biology, I don't know because I haven't done biology. Right? Other 3 subjects, I can give a small guidance. If you are doing ICT, then getting A for ICT is not a big deal at all. You all know that. Comparing with physics and chemistry subjects, ICT is really a basic subject. Right? I will guarantee A for physics if you are ready to work with me unconditionally. Right? Okay. 15. 15 idea. 15 idea. 15 angular velocity means velocity over radius. Angular velocity means what? Velocity over radius. Angular velocity equals velocity over radius. Over radius. Radius. Then dimensions of angular velocity equals dimensions of velocity over dimensions of time. Remember, you should put the square bracket. Then only the one who reading this question understands your meaning. You really want to mention dimensions of angular velocity, dimensions of velocity, dimensions of radius. Velocity dimensions L t to the power minus 1, L t to the power minus 1 over radius is also a length. Therefore, dimensions of radius capital L. Capital L. Finally, we are getting capital L cancel out. The remaining is capital T to the power minus 1. The remaining is, remember, capital T to the power minus 1. Simple, no? Simple. Question number 16. 16 idea. Angular acceleration. That is equal to acceleration over radius. Angular acceleration. Angular acceleration. That is what? Acceleration over radius. Acceleration over radius. Radius. Then the dimensions of angular acceleration going to be dimensions of acceleration over dimensions of radius. Acceleration dimensions, that is, we can remember capital L, capital T to the power minus 2 over radius is also a length, therefore dimensions of radius is capital L. Capital L. We can cancel out this capital L at the numerator and capital L at the denominator. We can cancel out. The remaining is capital T to the power minus 2. The remaining is, remember, capital T to the power minus 2, the remaining. Capital T to the power minus 2 remaining. Remaining. Therefore, remember, dimensions of angular acceleration should be capital T to the power minus 2. Story. Then 17, 18, 19. Number 17. 17 is momentum, means mass into velocity. 17. Number 17. Number 17. Number 17. 17. Now momentum, but we are calling it as linear momentum, but it's okay. Momentum means mass into velocity. Momentum equals mass into velocity. Mass into velocity. Dimensions of momentum should be equal to dimensions of mass into dimensions of velocity. Mass dimension is capital M, velocity dimensions capital L, capital T to the power minus 1. L T to the power minus 1. Therefore, remember, dimensions of linear momentum going to be capital M, L, T to the power minus 1. Simple story. Simple. 18, 19. Last three. Last three. Last three stories. Last three. Inertia means mass into distance squared. Inertia. Inertia means what? Mass into distance squared. Inertia. Question number 18, remember, inertia. Inertia equals mass into distance squared. Mass into distance squared. Right, okay, first time only we are experiencing physical quantity having a power greater than 1. Distance squared. First time only we are getting an equation, right? Having distance is having a power 2. I want to find the dimensions of inertia, that is mass into distance squared. So what you can do, if you want to find the dimensions of inertia, remember, that is equal to dimensions of mass into dimensions of distance whole squared. Do you understand? Now distance squared, no. Dimensions of distance whole squared. What should be the dimensions of mass? What should be the dimensions of mass? That is capital M. And what should be the dimensions of distance, that is capital L, distance squared, L squared. It's going to be capital M to the power 2. Capital M, capital L to the power 2. It's the answer. 19. Capital M, capital L to the power 2. Last story. Last story, then Planck constant means energy or frequency. Planck constant. Planck constant. That is equal to energy or frequency. Energy over frequency. Then what should be the dimensions of Planck constant? That is equal to dimensions of energy over dimensions of frequency. We wrote already dimensions of energy, that is how much, that is work done if from energy dimensions, that is ml squared T to the power minus 2. ml squared ml squared capital T to the power minus 2 over dimensions of frequency, that is capital T to the power minus 1. Why frequency dimensions we found? Frequency dimensions, that is capital T to the power minus 1. Frequency dimension, that is capital T to the power minus 1. Simple story. Then what will happen? Capital T to the power minus 2 over capital T to the power minus 1. Look here. Right. Then we know that what will happen when this capital T to the power minus 1 comes to the numerator? It will become capital T to the power plus 1. No? The capital T to the power minus 1 goes to the numerator. It becomes capital T to the power plus 1. Plus 1. Already there is capital T to the power minus 2 term, and now there is capital T to the power plus 1 also. Same base. We know same base. In that case, we can add the powers. We can add the exponents. Minus 2 plus 1. Minus 2 plus 1 is how much? Minus 2 plus 1 is going to be minus 1. Therefore, we can write down dimensions of Planck constant going to be capital M, capital L squared, then this capital T to the power minus 1. Nice story. Last 3 to be done, then story finished. Last 3. Last 3, then if you want, we can take a break and we can start the remaining stories. This is the dimensions. If you understood this idea, simple. Then we can completely finish the first 2 chapters in unit 1. And there is one section to be done, that is measuring instrument idea. We are doing in April's parallelly with unit 2 mechanics. Okay. Right. Last 3 velocity gradient. Last 3. Question number 20 velocity gradient. Question number 20 velocity gradient. Number 20 is what? Velocity gradient. Number 20. Number 20. Velocity gradient. Velocity gradient. This equals what? This equals what? Equation given, change in velocity over distance. Change in velocity over distance. Change in velocity over distance. Over distance. Right? Okay. Then the idea, very simple idea. Find the dimensions of velocity gradient. Find the dimensions of velocity gradient. Just put the velocity gradient in the square bracket and put the change in velocity in the square bracket, and then says that change in velocity dimensions over When you put the distance inside the square bracket, it says dimensions of distance. Finally, remember change in velocity is also the velocity. Remember change in velocity is also the velocity. What is the dimensions of velocity? Lt to the power minus 1. Capital L, capital T to the power minus 1 over distance dimension, that is capital L again. These two cancel out. Dimensions of velocity gradient going to be, remember, capital T to the power minus 1. Capital T to the power minus 1. Simple. Question number 21, last one to go. 21 story. Pressure gradient means what? Change in pressure over distance. Pressure gradient. Pressure gradient. That is equal to what? Change in pressure. Change in pressure over distance. Distance. And then quickly find the dimensions of pressure gradient. We already found the dimensions of pressure. If you can remember, just go to the previous questions. We found dimensions of pressure is what? ml minus 1 t minus 2. If you can remember, that is m capital L to the power minus 1 capital T to the power minus 2 over distance is capital L, no? Dimensions of distance is capital L. Again, when this capital L as the denominator goes to the numerator, it will become capital L to the power minus 1. Capital L to the power minus 1 into capital L to the power minus 1 becomes capital L to the power minus 2. Right? Capital M, capital L to the power minus 2, capital T to the power minus 2. This idea. Right? Now, some of you might have a kind of problem regarding simplification. Especially, sir, now we learned exponents, simplifying the power stories. We learned in maths. But, sir, still we learn those things, but still we can't remember. I can't remember these, why you are taking minus 1, how to add the powers, why it happens if we bring that denominator to the numerator, why it becomes negative or positive. Those stories, some of you can't remember. That's completely all right. To make those stories understand, we are doing a separate session that is we call as pre-physics program. Therefore, it doesn't matter, your level is not 0. Even your level is minus 10 also completely all right. We have set of work plans. We can bring you from minus 10, minus 20 to 100 degree Celsius. For an example, I'm telling 100. Therefore, you don't need to worry. Right? It doesn't matter what is your level, doesn't matter, because we have some set of work plans. Follow the work plans. I'm guiding you there. Step by step, grow yourself. Step by step. You don't expect yesterday, right? You don't know anything today. When you start learning tomorrow, you will be able to understand everything and you will get 100 out of 100. That's wrong. Right? Yesterday, you don't know anything. Today, you start learning, and tomorrow, if you're expecting to get 100 out of 100, that is impossible, right? But step by step, definitely, we have 2.5 year time period. Step by step, if we can climb the ladder step by step, definitely you can go to the peak for sure. By following our guidance, by following the advice that we give, if you can do that, definitely getting 3A is not a big deal, trust me. It's possible. Because many students, they have done that. People who got 3A's, if it is possible, I will ask them to come and talk in front of you people. The way how they got 3A's. Right, before coming to the classes, what were their level in the subjects? After coming to the class, how my class impacted their physics journey stories. If it is possible, definitely I will ask them to talk with you people. It's better, no? The people who already achieved 3A's, people who are already in the medical faculties, engineering faculties, if they come and talk with you, you feel more, right? No matter even that old person like me telling these advices, right? The people like me, we all know. If you tell some stories, sometimes you don't understand. You don't feel it, right? But better if you can bring the people who already got 3A's and who are in medical faculties, engineering faculties, if they come and if they talk with you, definitely you feel something. Yes, I want to work. I will like to work. I will work for sure. You will get that motive, very soon. If it is possible, I will call them and I will ask you to talk in front of the class. Then it will give a kind of inspiration for you all also. Last one to go, then we can take a break. Time is 7:20. We were doing the class for 1 hour and 20 minutes continuously. Last one. Last one is what? Last one is a gravitational constant. Last one. Number 22, last one. Number 22, last one. Last one, number 22, gravitational constant. Now, most of the physical quantities that you don't understand, that's completely all right. Entire lesson, what we are doing is we are learning each and every physical quantity descriptive manner. Therefore, you don't worry. Number 22, last one is gravitational constant. Gravitational constant. This equals force into distance squared over mass squared. Force into distance squared over mass squared. Right? And then if you want to find the dimensions of gravitational constant, that is equal to dimensions of force into dimensions of distance squared, dimensions of distance squared, dimensions of mass squared. Story. Last one. So force dimension is mlt minus 2. Capital M, capital L, capital T to the power minus 2 into a distance squared dimension is capital L squared over mass dimension is capital M squared. Right? So now there is one capital in the numerator and one, this capital M cancel out with this capital M. Only one capital M is remaining. As it comes to the numerator, it becomes capital M to the power minus 1. It becomes capital M to the power minus 1. Right? Capital M to the power minus 1. Okay. Again, there are two capital L terms. Capital L to the power 1. Capital L to the power 1 into capital L squared. And then 1, 2 means 3, no? Capital L to the power 3. Capital T to the power minus 2. Capital T to the power minus 2. Done and dusted. Finished. Very simple. Actually, what we have done today, we start the class at 6 o'clock. Right time is 7:25 almost. Actually, we talked about today. We started dimensions theories. Basically, what does it mean by dimensions of a physical quantity? Right? We are analyzing the relationship between any physical quantity with mass, length, and time. So we are assigning a symbol for mass, capital M, length, capital L, and time, capital T, and we are going to check how each and every physical quantity linked with mass, length, and time. Then you are getting a kind of symbolic expression in terms of capital M, capital L, capital T. That symbolic expression going to be the dimensions of that certain physical quantity. Only important story is every time writing dimensions of, we are using a square bracket. If you write a symbol of physical quantity inside the square bracket, the meaning is dimensions of that physical quantity. When you are writing the dimensions of physical quantity, normally we follow capital M, capital L, capital T. That's it. I think everyone in the class, every story we learned till now, I think everything is very clear, I think. Time is 7:25. We can take a small break, 15 minutes. Time is 7:25, come at 7:40. Then we are talking the remaining theories under dimensions. We'll take a break. We can take a small break and come at 7:40. Drink something, eat something, and come. Okay. Drink something. So then, we understood what is dimensions of physical quantity, and the stories we understood. No, idea is clear. No, this idea is clear. Right, we'll go to the next theories regarding dimensions. Next theories. Right. The next theories. Take your attitude to the next theory. Right. So then page number 11, that first point. Okay, now we talked about dimensions of physical quantities. Now we have done a question also. We have a good understanding about how to find the dimensions of every physical quantity. We have a good idea. Right. Then page number 11, red color pen write down. Page number 11, red color pen write down. Pure numerical values are dimensionless. Pure numerical values are dimensionless. Now some people have a doubt, so what does it mean by dimensionless? Remember, dimensionless means when you are finding dimensions of something, maybe you are finding dimensions of physical quantity. If not, maybe you are finding dimensions of something else. When you obtain, if it is dimensionless, remember, what will happen for the power of capital M, power of capital L and power of capital T? Becomes 0. Remember, if there is a physical quantity or any other thing is dimensionless, remember, the power of capital M, capital L and capital T must be 0. Dimensionless. That physical quantities, that something's power, that something's power of capital M, power of capital L and capital T must be 0. So then we call that physical quantity or that something is dimensionless. Right? Then, sir, what are the physical quantities which do not have dimensions? So what are those something which do not have dimensions, which are dimensionless? Number one is, remember, pure numerical values are dimensionless. First one, write down, pure numerical values are dimensionless. What are the pure numerical values? 1, any number. 1, 5, 2.5, any fraction. 2 × 2/7, 3/4, they all are numerical values. All the numerical values are dimensionless. Example, right? Pure numerical values. Pure numerical values are dimensionless. They don't have dimensions. Right? Numerical values. Example, in any number, you can write any number. Example, any number, right? It can be 1, it can be 25, 100, 1 lakh, 10,000, any number. 2, 100, any fraction value, 3/4, right? And also in decimal value, 0.95, these all are numerical values, therefore they don't have any dimension. If not, they are dimensionless. Also remember, pi means, we all know that 3.14. If not, pi means what? 20/7. Pi is also dimensionless. It's a value, no? That symbol pi represents the value. The symbol pi represents the value, therefore it is also dimensionless. And also people who do A max, they will know that exponent simple e, this is also dimensionless. Simple e also represents the value, but you don't want to bother with what is simple e, just write down simple e also does not have any dimensions. Don't misunderstand, simple is not a simple letter of English alphabet. Simple is a thing that we call for as exponent something. right? Okay. Then example below this point, write down these examples. The next point, write down next point. Ratios of identical quantities are dimensionless. Right? Next point. Next point, write down. Ratios of identical quantities are dimensionless. In your syllabus, right? The next one is ratios of identical quantities. We will learn these physical quantities. Ratios of identical quantities. What does it mean? Let's consider now in your syllabus you will learn a physical quantity called relative density. In mechanics under hydrostatics we will talk what is relative density. That is what we call a specific gravity also. Relative density means, remember the equation. The equation is density of any substance over density of water. Relative density. Example. This physical quantity does not have any dimensions. The reason I will show you. Relative density. The equation is, remember, density of any object, any substance over density of water. Density of the object over density of the water. Density of water. Water, WATR, water. Then let's try to find the dimensions of relative density. Just find it. We all know that relative density dimensions, this equals to density of object dimensions and over density dimensions of density of the water. Right? What is the dimensions of density of the object? We learned any object, any substance, dimensions, density. That is how much? Capital M, L to the power minus 3. So we all know that. Capital M, capital L to the power minus 3. Then what are the dimensions of water density? What should be the dimensions of density of the water? That is also ml to the power minus 3. ml to the power minus 3. Then what happens? What happens now? We can simply tell that capital M cancel out. Capital L to the power minus 3 cancel out with capital L to the power minus 3. We can tell like that. Then the answer is 1. That is also correct. We can cancel out this capital M term. And one can cancel out capital L minus 3 term with capital L to the power minus 3 term. Then the answer is something 1. No? Answer is 1. Then we can tell that this physical quantity does not have a dimensions. But we can write other way also. When you consider the capital M, in the numerator the power is what? Power is 1. The capital M at the denominator the power is also 1. What will happen when this capital M to the power 1 comes to the numerator? It will become capital M to the power minus 1. Okay? Then we know that, see here, capital M to the power 1 is already in the numerator. If you bring this capital M to the 1 also to the numerator, if you bring this capital M to the 1 also to the numerator, that is going to be capital M to the power minus 1. Okay? Already this capital L to the power minus 3 is in the numerator. Capital L to the power minus 3 is in the numerator into, when you bring this capital L to the power minus 3 in the denominator to the numerator, what will happen? When you bring capital L to the power minus 3 in the denominator to the numerator, it becomes capital L to the power plus 3. Capital L to the power plus 3. When you simplify, what will happen? We simplify it. Just simplify it. So when you simplify it, you are getting what? You are getting what? You are getting a capital M into capital M to the power 1 into capital M to the power minus 1. Same base, capital M. Then we can add their powers. 1 minus 1. When you add their powers, what is the answer? The base is capital M. If you add their powers, 1 minus 1 going to be 0. Capital M to the power 0. We are getting capital M to the power 0. Likewise, find the capital L to the power minus 3 into capital L to the power 3. If we simplify it, same base, capital L, then you can add their powers minus 3 plus 3, 0. We are getting capital L to the power 0. Then we, very clear, relative density is dimensionless. Remember, dimensionless means when you check the powers of capital M, capital L and capital T, they should be zeros. We know that all levels you will learn that when you consider any number 0 power, 1 to the power 0, if not 2 to the power 0, if not let's say 5 to the power 0, x to the power 0, y to the power 0, we all know that is equal to 1. 2 to the power 0 is also 1. 5 to the power 0 is also 1. X to the power 0 is also 1. 1. Therefore, what we can tell that dimensionless means power of capital M, capital T should be 0. If not, that is equal to 1. That is equal to 1. Then it is dimensionless, right? But this is the idea. This is the idea. Clear now? Then very clear. The what you can cancel out capital M, then you can cancel out L to the power minus 3 and L to the power minus 3, then you are getting 1 only. Then we understood relative density is dimensionless. Do you understand? In this equation, density of the object has dimensions. Density of the water is also having dimensions. But if you take the ratio of identical quantities, density. If you take the ratio of identical quantities, density, then this physical quantity does not have any dimensions. Likewise, in your syllabus, we are talking there are lots of physical quantities having dimensionless, right? Other example is I have given, right? In the given example, you can write down, right? I wrote the ratios of identical quantities. Ratios of identical quantities are dimensionless. Example, write down below, example below, write down. Relative density, comma, strain, comma. If you don't know what strain is also, okay, we will learn. Relative density, comma, strain, comma, refractive index. In optics, we will talk about refractive index. They all are dimensionless. Example, write down relative density, comma, strain, comma, refractive index. They don't have dimensions. Alright, now I took this example to show you why relative density does not have dimensions, since the definition of relative density is density of any substance over density of the water. The ratio is having identical physical quantities, density. As a result, when you find the dimensions, the power of capital M, capital L, if there are capital T, all the powers are 0. Therefore, they are dimensionless. Likewise, strain means, remember the equation. Number 2, strain means, remember. Second example is change in length over initial length, if not original length. Right, we will learn these stories. Under unit 10 properties of materials, we will talk about strain. Strain means, you know the equation. Strain is, remember, strain equals a change in length over original length. Change in length over original length. Original length. And now this equation, right? This physical quantity definition is also a ratio of identical physical quantities. What do we mean? Change in length is also a length. Original length is also a length. Then we learned that the ratio of identical quantities are dimensionless. We'll check that. We'll check and confirm whether strain has dimensions or not. when you find the dimensions of strain, we can write down dimensions of change in length over dimensions of original length. Change in length as well as original length, they all are lengths. Therefore, what is the dimensions of change in length? That is capital L over dimensions of original length is also capital L. Then capital L, capital cancel out. The result is 1. That means strain is dimensionless. But one can write down the power of the L in the numerator is 1. Power of the L at the denominator is also 1. When this L to the power 1 at the denominator goes to the numerator, when this L to the power 1 goes to the numerator, it becomes capital L to the power minus 1. Then same base capital L, powers are 1 minus 1. When you simplify it, you are getting the answer L 1 minus 1 is 0, no? L to the power 0. Then it says that strain is dimensionless. Right, likewise number 3 is third example. Write down. Third example I have given. Third example is refractive index. We will learn under optics, we will define what's refractive index. I will teach you their huge description and big stories. Refractive index, the equation is, remember, speed of light in vacuum over speed of light in a medium. Number 3, refractive index. Number 3, refractive index, the equation is speed of light in vacuum over number 3, refractive index. Third example, refractive index. Refractive index equation is, remember, speed of light in vacuum. Don't worry, what is a vacuum? I will teach you upcoming classes. Anyhow, speed of light, speed of something over speed of something. Again, the ratio is having identical quantities, therefore refractive index also dimensionless. Speed of light in vacuum. Speed of light in vacuum, I don't write down that story, over speed of light in the medium. Speed of light in the relevant medium. I don't write the medium, okay? Speed of light, blah. The medium. Then if you want to find the dimensions of refractive index, that is equal to dimensions of speed of light in the vacuum over dimensions of speed of light in the medium. Dimensions of speed of light in the medium. Let's give a try. Then it's a speed dimensions LT minus 1, doesn't matter. Speed of light or whatever the medium doesn't matter. If it is a speed, dimensions of speed is, we all know, LT to the power minus 1. Capital L, capital T to the power minus 1. Over, again, speed of light of something. Capital L, capital T to the power minus 1. You can cancel out. L cancel out. T minus 1, T minus 1 cancel out. The result is 1. If not, one can write down, if you bring this capital L to the numerator, it will become L to the power 0. If you bring again capital T to the power minus 1 at the denominator to the numerator, if you bring this capital T to the power minus 1 in the numerator, my bad. If you bring this capital T to the power minus 1 at the denominator to the numerator, it will also, if you simplify it, you are getting capital T to the power 0. Then this is also dimensionless. Simple. Then idea almost okay. Idea understood. In numerical value, they do not have dimensions, therefore they are dimensionless. And also there are physical quantities in our syllabus. They are defined as ratio of same identical quantities. For example, if relative density means density of something over density of something, right? Then strain means change in length over length something. Then remember, those also having no dimension, they are dimensionless. Story is okay, no? Story is okay. Next one is somewhat important. When you are doing MCQs, you will get huge number of questions linked with this idea. Next point, write down. Next point, angles, red color pin. Angles inside the bracket, plane angle and solid angle are dimensionless. Very important. Angles inside the bracket, plane angle and solid angle. Normally we don't talk about solid angle ideas, but we talk about plane angle stories in our syllabus. right? Angles inside the bracket, plane angle and a solid angle, close the bracket, are dimensionless, full stop. But they have units. Highlight entire sentence also. Angles are dimensionless, highlight, angles are dimensionless, full stop, but they have units. But they have units. Highlight entire sentence. What does it mean? What does it mean? Right? Now, can you explain angle in terms of mass, length, time? Let's consider plane angle. Plane angle is, we know now when you consider now, this is what we call as plane angle. Generally in maths classes, right, in maths we measure the plane angle in radians. Rarely we are using minutes and seconds in maths. But in physics, not last week, I think, before last week we learned what is the SI unit to measure the plane angle. That is radian. Also we define plane angle is a supplementary quantity. Right? This story we learned. Remember, this plane angle, plane angle does not have any dimensions. They are dimensionless. But we all know that plane angle has a unit, no? Sometimes we are using degrees, minutes to measure the angle. Also, plane angle has a SI unit, that is radian. RAD, simple R, simple D. Therefore, definitely plane angle has a unit. But remember, plane or solid angle, any angle, they do not have any dimensions. Therefore, write down below if you want, write down below. Any angle, plane angle or solid angle. Plane angle. If you want to find the dimensions of plane angle, remember, put the plane angle inside the square bracket. When you put the plane angle inside the square bracket, dimensions of plane angle going to be what? Capital M0 equals to what? Capital M to the power 0, capital L to the power 0, and capital T to the power 0. 0. This idea. Plane angle does not have any dimensions. This story. Last point also red color pen write down. Last point, red color pen write down. Last point. Write down. Trigonometric and logarithmic functions are dimensionless. Now next week we'll have an exam, okay? A nice exam. Right? Trigonometric and logarithmic functions are dimensionless. Right? So we all know trigonometric and logarithmic functions. For example, if I ask you a sine angle, no? In the bracket, what comes inside the bracket? Sine inside the bracket, what comes? Definitely there should be an angle in the brackets, no? Sine angle, for example, sine 30 degree. How much? If you can remember the value, sine 30 degree means exactly half. Remember, sine angle, that is sine any kind of angle. It can be any angle. Trigonometric function, sine that angle, the value is half. That means what? This trigonometric function, sine angle, this entire sine term, entire this trigonometric function does not have any dimensions. Because why? The result is what? Sine angle result is always a value, no? Sine 30, sine 45, sine 60, sine 90, sine 30 is half. Sine 45 degrees how much? Sine 45 degrees how much? 1 over root 2, if you can remember the values. Sine 60 is how much? That is root 3 over 2. So remember, always any sine angle is a value, a numerical value. Do you think numerical values have dimensions? That's not we learned. Numerical values, they don't have dimensions. Therefore, sine any angle does not have dimensions. Therefore, sine angle, any logarithmic, any trigonometric functions are dimensionless. Cos angle and tan angle, these all are we are calling as trigonometric functions. Trigonometric functions, they don't have dimensions. Trigonometric functions. They don't have dimensions. Not only trigonometric functions don't have dimensions, remember, logarithmic functions also don't have dimensions. For example, log. All of us you learned, log. Base is 10, normal log 10, any value. The result is no dimension. You are getting a value, no? Log 10, log 10, 100 is how much? If you can remember all level story, log the base is 10 and the value is 100, the power is how much too? And the result of this logarithmic function is a numerical value. Therefore, logarithmic functions also do not have dimensions. So what you do in the given space, write down sine bracket, cos bracket, tan bracket, mention they are trigonometric functions. And then write down this log base a bracket. This is write down logarithmic function. Logarithmic function, and this one also does not have any dimensions. The story. Okay, the story. Okay. So now I think we talked about some good stories. No? I think idea is very clear. Right, every point is very clear. I think right, very simple story. Now we have to do questions. Now we want to go from the beginning and we should do the questions. Right, I think everyone, normally if it is a Zoom class, I ask everyone to raise your hands and tell me whether you understood or not. Since it's a YouTube session, I think you can't raise your hands and you can't respond. But anyways, I think we learned some new stories. Right, time is 8:10. I think this month we did the classes entirely fully free of charge, and because you should have freedom, no? Because you are selecting the most difficult streams in A levels. And therefore you should select the right classes. So definitely the classes that you select will definitely guide you for your success for sure. In that case, to get a kind of exposure about our classes, I tried to make you free access throughout the month. I think it's our third theory class, but already for this month we have done 4 classes. First day we didn't do anything, we just talked some stories. Second, third, today is the 4th week we were doing classes. Right, then people who requested the PDF, not the printed versions of Tute, I posted them. The next story is April month, first week itself, we are posting measuring instrument Tute, and we are posting unit 2 vectors Tute. Measuring instrument and vectors Tute we are posting in April month, and also we are doing classes throughout the April month via the Zoom. Not YouTube. Normally, generally, we don't do class via the YouTube. Okay, only for the first month we done class via the YouTube, but normally we do the class with the Zoom because students can ask questions privately and we can communicate very well. We can clarify their doubts, and as a team, as set of friends, bunch of friends, we can do the class. No? That's the way of we are doing the classes. Right? If you have anything to be clarified, if you have any doubts, you can put a WhatsApp message and you can ask your doubts. Sometimes I might take some time to respond to your messages, but definitely I reply. It takes some time, but definitely I reply. Okay. So then dimensions, we have applications of dimension, and we want to talk about dimensional analysis. That is a kind of somewhat complex section. Dimensional analysis story, somewhat complex idea. Only that is the last part in dimensions. If we discuss that story, then theory wise everything is finished. Right, dimensional analysis is the last section. Then the Tute is completely finished. But what shall we do, since it's a big part? We'll do this dimensions analysis. That part we'll do next week. And next week we can start vectors also. Right, next week we are starting vectors and we are completing dimensions and we are doing questions. There will be a kind of unit paper regarding unit section, set of MCQs. Prepare for the exam and come, but it's not a big exam, just giving few questions, and within few minutes you should try and you should send me. They are not difficult stories, it's easy. Right, I think Sachin is very effective today, so we can stop the classes for today. But generally we are doing classes, in the beginning we are doing the class for 3 hours, maximum 3 hours in the beginning. Sometimes I will stop the class for 2.5 hours. Sometimes mostly I do the class for 3 hours. Mostly, very rarely I stop the class around 2.5 hours to 3 hours. But within 1 or 2 months later, we are increasing the class duration to 3.5 hours, 4 hours. Then after 6 months later, we are doing the classes for 4.5 an hour for 1 year. Based on the content to be covered, sometimes duration can extend to 5 hours maximum. Maximum 5 hours. But just now sometimes you feel like how it's possible, even focusing for 2 hours is not easy. But with the time you also adapt to A-level story, then easily you will adopt it. Because our 27 batch students and 26 batch students, they are joining for 5 hour, 4.5 hour classes. Therefore, don't worry, trust yourself and work with me properly. Definitely we can go for A result. Then session is finished. If you have anything to be clarified, you can ask me at the WhatsApp, then I can clear your doubts. Right? Then let's meet on next week.